Welcome to another video. We are now in chapter 3 of general mathematics lesson. The topic for today is the use of Pascal's triangle in binomial expansion. First of all, let us consider the expansion of the following. A plus b raised to power 0. We know that any number raised to power 0 is 1. There are two terms there, A and B. That's why we call it binomial. That's why we call it binomial. So if we remove the bracket, then we now have the expansion. Now as it is, A plus b raised to power 0 is 1. The next one, A plus b raised to power 1 is what? A plus b. 1 stands for the coefficient of A and B. And then the second one, A plus b raised to power 2 is what? If you expand it, you have a squared plus 2ab plus b squared. The 1 there is the coefficient of a squared and b squared. The next one, a plus b raised to power 3 is what? 1 times a raised to power 3 plus 3a raised to power 2 b raised to power 1 plus 3a raised to power 1 b raised to power 2 times, plus 1 times b raised to power 3. Then a plus b raised to power 4, you now have 1 times a raised to power 4, where 1 is the coefficient of a raised to power 4, plus 4 times a raised to power 3 times b raised to power 1, plus 6 times a raised to power 2 times b raised to power 2, plus 4 times a raised to power 1 b raised to power 3, plus 1 times b raised to power 4. Now the next one is what? A plus b raised to power 5, which is equals to 1 times a raised to power 5 plus 5 times a raised to power 4 times b raised to power 1 plus 10 times a raised to power 3 times b raised to power 2 plus 10 times a raised to power 2 times b raised to power 3 plus 5 times a raised to power 1 times b raised to power 4 plus 1 times b raised to power 5. Now, we are going to isolate only the coefficients of A and B. From the isolation, you can see that the coefficient of A and B form a triangle, which we call Pascal's triangle. Now, what do you notice from this Pascal triangle or from the expansion? From the expansion, you notice that the sum of the powers of each term is equal to the power in the original expansion. What do I mean by that? If you look at a plus b raised to power 1, if you take the sum of the powers of a and b, here is 1, here is 1. Of each term is equal to the power in the original expansion, like I've said earlier. If you look at a plus b raised to power 1, you see a here is raised to power 1, a plus b raised to power 1. B here is raised to power 1, a plus b raised to power 1. The next one, a plus b raised to power 2. The first term here is what? A raised to power 2. You see that 2 here, 2 in the original expansion. You see this one, a raised to power 1, b raised to power 1. 1 plus 1 is 2. Then b raised to power 2 here, 2 there. Then the next one, a plus b raised to power 3. You have here 3. You have 2 plus 1, 3, which is 3 there. 1 plus 2, 3, which is 3 here. And 3 here is 3 there. Now the next one, a plus b raised to power 4. The first time here is a raised to power 4. The power there is 4. Here 3 plus 1 is 4. 2 plus 2 is 4. 1 plus 3 is 4 and 4. The next one, a plus b raised to power 5. The first term here is what? 5 here. A raised to power 4, b raised to power 1. 4 plus 1, 5. 3 plus 2, 5. 2 plus 3, 5. 1 plus 4, 5. And then 5. So, the sum of the powers of each term is equal to the power in the original expansion. Now, before we go to other things we will discover from Pascal triangle, now you can generate other powers, the coefficient of other powers. Since you know that a raised to power 0 is 1, you can now say nothing plus 1, 1. Nothing plus 1, 1. Nothing plus 1, 1. 1 plus 1, 2. Nothing plus 1, 1. Nothing plus 1, 1. 1 plus 2, 3. 2 plus 1, 3. Nothing plus 1, 1. Nothing plus 1, 1. 1 plus 3, 4. 3 plus 3, 6. 3 plus 1, 4. Nothing plus 1, 1. Nothing plus 1, 1. 1 plus 4, 5. 4 plus 6, 10. 6 plus 4, 10. 4 plus 1, 5. Nothing plus 1, 1. So you follow that same procedure and generate other coefficient or coefficient of other binomial expansion using this procedure. Now, another thing you discover after getting the coefficient, you discover also that in this expansion, A is what? Decreasing from 1 to 0, while B is what? Increasing from 0 to 1. Invariably, we are saying that the first term decreased from n to 0, and the second term increased from 0 to n, where n is the power. Now, a plus b raised to power 2. You see, a decreased from 2 to 0, b increased from 0 to 2. Now, this is the first term is what? A raised to power 2. Now, in the next expansion, in the next term, a has reduced to 1. It's now a raised to power 1. Here b is raised to power 0. Here b is now raised to power 1. In the last term, a has what? Decreased to 0, which means a raised to power 0 is 1. That's why we have 1 there. And then, sorry, there's 1, even though we didn't write it. And then b has increased from 1 to 2. Now, in this other expansion, a plus b raised to power 3, a is decreasing from 3. Here is 3. B is supposed to be b raised to power 0, which is 1. That's why we don't have b here. Here, a has decreased from 3 to 2. We now have a raised to power 2. B has increased from 0 to 1. Here, a again has decreased to 1. B has increased to 2. And here, the last term, a has decreased to 0. B has increased to 3. That's what it's called. Then a plus b raised to power 4. A has what? A is now raised to power 4. B is now increasing from 0. So here is 1. That's why you cannot see B. Here, A has decreased from 4 to 3. You now have A raised to power 3. B has increased from 0 to 1. Here, A has decreased from 3 to 2. B is now increasing from 1 to 2. And then here, A has decreased from 2 to 1. B is now increasing from 2 to 3. And here, A has decreased from 1 to 0. B has increased to 4. Then A plus B raised to power 5. Here, A is now raised to power 5. B is increasing from 0. That's why you don't have B here. A has decreased from 5 to 4. B is increasing from 0 to 1. Here, A has decreased from 4 to 3. B is increasing from 1 to 2. Here, A is decreasing from 3 to 2. B is increasing from 2 to 3. Here, A has decreased from 2 to 1. B has increased from 3 to 4. And here, A has decreased from 1 to 0. And here, B has increased from 4 to 5. So, with that, you can comfortably solve problems involving binomial expression. When you are giving a binomial expression to expand, once you generate the coefficient, the next thing is use the policy or the concept that the first term is decreasing from n to 0, while the second term is increasing from 0 to n, where n is a positive integer or positive integer. So at this point, we are going to solve some problem using the Pascal triangle. As you can see, the array forms a triangle. So we are going to use this array of numbers, of coefficients, to solve some problems involving binomial expression, expanding binomial expression. Yes, as I said earlier, we are going to solve problems using the array of Pascal triangle, or array we call Pascal triangle. Problem 1, expand and simplify completely 3a plus 4b raised to power 4. Then the solution from Pascal's triangle, the coefficient of a plus b raised to power 4 is what? 1, 4, 6, 4, 1. Now, 3a plus 4b raised to power 4 is what? Now we first of all look at the coefficient. The first coefficient there is 1. Like I said earlier, the first term is decreasing from n to 0. And the second term is increasing from 0 to n. N here is 4. So you now have that 1 times 3a raised to power 4 times 4b raised to power 0. Then the next one, the coefficient is 4. 4 times, now the first term 3a is now decreasing by 1. So it's now 4 times 3a raised to power 3. The second term 4b is now increasing from 0 to 1. So the decrease is by 1 and the increase is by 1. So this is now 3a raised to power 3, 4b raised to power 1. The third term, the coefficient there is 6. The first term is what? 3a is now decreasing from 3 to 2. We now have 3a raised to power 2. And the second term, 4b, is increasing also from 1 to 2. So it is now 4b raised to power 2. Then the fourth term, the coefficient there is 4. The first term is decreasing from 2 to 1, which is now 3a raised to power 1. And the second term, 4b, is increasing from 2 to 3, which is now 4b raised to power 3. And the coefficient of the last term is 1. The first term is 3a, is now decreasing from 1 to 0, while the second term 4b is increasing from 3 to 4. So we have 4b raised to power 4. Now, 3 raised to power 4 is what? We have to open the bracket. We have 3a raised to power 4, a raised to power 4. 4b raised to power 0 is 1. That's why you have 1 there. You now have 4 times 3 raised to power 3, a raised to power 3, 4b raised to power 1. 6 times 3 raised to power 2, a raised to power 2, 4 raised to power 2, b raised to power 2, plus 4 times 3, a raised to power 1, 4 raised to power 3, b raised to power 3, and then 4 raised to power 4, b raised to power 4. Now we are going to expand completely to get to the final answer. 3 raised to power 4 is what? 3 multiply itself 4 times. 3 times 3 times 3 times 3, that's 81 a raised to power 4. Then 3 raised to power 3 is what? 3 times 3 times 3, 27. And then 4 times 4 is 16. 27 times 16 is 432 a raised to power 3, b raised to power 1, or b. Then 6. 3 raised to power 2 here is 9. 9 times 6 is what? 54. 54 times what? 4 square, which is 16. 54 times 16 is 864 a raised to power 2, b raised to power 2. Then 4 raised to power 3 here is what? 64. 4 times 4 times 4. 64 times 4, 3, 12. That's 12 times 64 is what? 768 a b raised to power 3. Now 4 raised to power 4 is what? 4 multiply itself 4 times. That's 4 times 4 times 4 times 4. That is 256. b raised to power 4. So this is the complete expansion of 3a plus 4b raised to power 4. Now the second problem is taken from y. Write down the first 4 terms of the binomial expansion of 2 minus half x raised to power 5 in ascending power of x. Now from Pascal triangle, the coefficient of a plus b raised to power 5 is what? 1, 5, 10, 10, 5, 1. Now from the question, we are to only consider the first 4 terms. So we are going to stop here. 1, 5, 10, 10. That's where we are going to stop. Now we have to rewrite this expression 2 minus half s raised to power 5. We can write it as 2 minus half s raised to power 5 equals to 2 plus minus half x all raised to power 5. All raised to power 5. 2 plus minus half s all raised to power 5. Now we will have to rewrite it to take the form of a plus b, where 2 is a, or where a is 2 and b is minus half x, or everything raised to power 5. Now the coefficient of the first term is 1, and the first term is what? 2 raised to power 5. Remember, we say that the first term will decrease from the highest power, which is n, to 0. And the second term will increase from 0 to the highest power, which is n. Here, n is 5. So we have 2 raised to power 5 minus half s raised to power 0. The coefficient of the second term is 5. Now, 2 is decreasing from the power 5 to power 4. So we now have 2 raised to power 4. And minus half x is increasing from 0, from the power 0 to 1. We now have minus half x raised to power 1. And the third term here, the coefficient of the third term here is 10. So the first term is what? Is now decreasing from the power 4 to power 3. So we now have 2 raised to power 3. And the second term is increasing from the power 1 to power 2. We have minus half s raised to power 2. Now the fourth term is, the coefficient of the fourth term is also 10. The first term is now decreasing from the power 3 to the power 2. You now have 2 raised to power 2. And minus half s, which is the second term, is increasing from the power 2 to the power 3. So you now have minus half s to power 3. From the question, we are to take the first 4 terms. So this is the fourth term. We stop there. Now we expand completely. 2 raised to power 5 is what? 32. Minus half s raised to power 0 is 1. So you have 32 times 1, 32. 2 raised to power 4 is what? 16. 16 times 5 is what? 80. Times minus half is what? Minus 40x, because x is raised to power 1. So it's minus 40x. Now the third term is what? 2 raised to power 3 is what? 8. 8 times 10 is 80. Minus half raised to power 2 is what? 1 over 4. So 80 divided by 4 is 20. And then you have s squared, 20s squared. And then here, minus half raised to power 3 is minus 1 over 8. That's why you have minus there. And then 10 times 4 is 40. 40 divided by 8 is 5. So this is the complete expansion of the first 4 terms of the expansion of this binomial expression. Now, problem 3. Write down the binomial expansion of 1 plus x raised to power 4. That's A, the A part. The B part, use the result in A To evaluate, correct to 3 decimal places. 5/4 raised to power 4. This question is also taken from WAEC. Solution to problem 3. From Pascal's triangle, the coefficient of a plus b raised to power 4 is what? 14641. Now, 1 plus n raised to power 4 is equal to what? The coefficient here, the first coefficient of the first term is 1. The first term is 1, which is now 1 raised to power 4. And the second term is s raised to power 0. Plus the coefficient of the second term is 4. Now, the first term 1 is decreasing from 4 to 3, which is now 1 raised to power 3. Even though 1 raised to power any number is 1, we need to write it down for clarity purpose. So you now have, it's not the first term 1 is now decreasing from 4 to 3. We now have 1 raised to power 3. And the second term is increasing from what? 0 to 1. We now have s raised to power 1. The coefficient of the third term is 6. First term is now decreasing from 3 to 2. We now have 1 raised to power 2. That's from power 3 to power 2. We now have 1 raised to power 2. And the second term is increasing from power 1 to power 2. We now have s raised to 2, or f raised to power 2. Then the coefficient of the fourth term is 4. And the first term is now decreasing from power 2 to power 1. We now have 1 raised to power 1. Even though we refuse to put 1 raised to power 1, put the 1 there. It doesn't matter. It's 1 raised to power 1. Then the second term s is increasing from power 2 to the power 3. We now have s raised to power 3. And the coefficient of the last term is 1. First term is now decreasing from power 1 to power 0. We now have 1 raised to power 0. And the last second term is what? Increasing from power 3 to power 4. We now have s raised to power 4. So we now expand completely. 1 raised to power 4 is 1 times 1 is 1. S raised to power 0 is 1. So everything is 1. 4 times 1 times s is 4x. 6 times 1 times s squared is 6s squared. 4 times 1 times s cubed is 4s cubed. 1 raised to power 0 is 1. 1 times 1 times s to power is s raised to power 4. That is the complete expansion of 1 plus s raised to power 4 using Pascal's triangle. B part, we have to use the above expansion to simplify or evaluate 5/4 raised to power 4. Now, 5/4 is the same thing as 1.25. We have to convert this fraction to decimal. And when we convert, we have what? 1.25, which is raised to power 4. Now, we need to rewrite this 1.25 to look like this expansion here. What? The 1 has to be in this position to look, to take the shape of the binomial expansion we have to use the expansion. So 1.25 raised to power 4 can be, rewritten in a form 1 plus 0.25 raised to power 4. Of course, 1 plus 0.25 is the same thing as 1.25. So we write it in this form so that it will take the shape of this expansion. So we now say that x is now 0.25. So we are now going to replace this value in this expansion. So we now have that 1 plus 0.25 raised to power 4 is equal to what? 1 plus 4. In place of x, we put 0.25. 6 times 0.25 squared. 4 times 0.25 cubed, and 0.25 raised to power 4. In place of x, we have to substitute 0.25, and then we expand. And that's what we have done here. 4 times 0.25 is 1, so we have 1 there. 6 times 0.25 raised to power 2, we have 6 times 0.0625. 0.25 raised to power 3 is 0.01565 times 4. And this one here, the last one, is what? 0.003906. Now, adding everything together, we're going to have 2.441 to 3 decimal place. 3 decimal place means 4 digit. Sorry, 3 decimal place means 3 digit after the decimal point. 3 digit after the decimal point will give you 3 decimal places. You have 2.441. You have 3 digit after the decimal point. So that gives us the correct answer. Now, this is exercise 3. I will advise you to solve these problems using the above examples we have solved. Follow it strictly and you'll be able to solve them correctly. You have the question 1. Write down the binomial expansion of 2 minus x raised to power 5 in ascending power of x. B. Use your expansion in A to evaluate 1.98 raised to power 5 correct to 4 decimal places. That is taken from y also. Then number 2, A. Using the binomial theorem, write down and simplify all the terms in the expansion 1 plus half x raised to power 6. B. Use the expansion in A to evaluate 1.005 raised to power 6 correct to 5 decimal places. Thank you for watching and listening.